am recording now. So before we actually jump into the review, I realize some of you might not have been here on Tuesday, so I would like to share my browser with you and show you where this is in our course. Okay, we are currently in week 5. Okay, so we did the linear programming with Excel when we met last time on Tuesday. And let me just mention this to some of you, okay? I went over using Excel 365 because I know everybody has a subscription to Office 365. I know a lot of you also have desktop Excel. The directions in the notes that I uploaded as shared files with the video from Tuesday walk you through the process for getting the solver added in and how to use it in desktop Excel. If you still need help with that, please feel free to contact me. I know some of you have sent me links from homework problems, and you have to realize I respond to those, but you've got to look at the messages in more. So when you open up a homework, you'll see a little flag that says you've got a message, okay? I make it a point to respond to everybody right away. So if you did ask a question, again, please make sure you check for a response, okay? I don't ignore students, okay? Especially with something like Excel. I know it's not always straightforward how to set up these add-ins, okay? So if you need help, please reach out. But again, what we did on Tuesday was using Excel in Office 365. So again, it's up to you how you want to solve these problems. You can use Office 365, you can use desktop Excel, and as I mentioned, you could even, if you wanted to, graph a feasible region in Desmos and do it the old-fashioned way, but that takes longer, okay? Using a modern tool was not only more efficient, but it gives you practice in using the tool, okay? So what we're going to be doing today is essentially what I've done is, you see this practice exam here? Okay, this exam is not going to count in your grade insofar as whatever you do on it, that's fine. You'll get full points because it's a practice exam. I just want you to see the types of questions that are going to be on this exam. You can see they're about 20 points, right? So essentially, what I did was I printed off my version of the practice exam. Please understand, the exams pull from a test bank, so you won't get exactly the same questions, but you'll get a similar type of question. Okay, so the point isn't, hey, you did a question on mixture of different coins, and my test didn't have a question like that. No, but your test had a mixture problem. So what's important is to understand how to solve that type of problem, okay? How are we doing so far? Any questions so far? Okay. All right. The hardest thing about these problems, okay, the problems that you're solving in Excel, is being able to break down the words into what's called a standard maximization or standard minimization problem. And honestly, that's a critical reading issue, okay? Again, you start at the end of the problem, and you try to determine what you're being asked for. Those are your decision variables. You try to figure out what you're trying to maximize or minimize. That's your objective function, and it's usually in terms of the decision variables. Anything that's left in the problem is a constraint. It's something that's working against you maximizing or minimizing your objective, okay? But again, that's what the bulk of the problem's work is going to be that translation step. Again, if you have trouble with a particular homework problem, like translating it, then please email me. Click that message instructor link, but then make sure you go back and check for a response, because you will get a response that same day. Okay? Unless you email me at 11 o'clock at night. Okay? Then you'll get a response the next morning. All right, any questions so far? Questions so far? Okay, I want to make sure everybody understands the practice is for you to like just bang on and see how it works. This is the real thing. See Unit 1 exam? All right, you've got to do the Unit 1 exam by 11:59 p.m. on Sunday. Okay? And if I just kind of click into this, just to show you. This would be the day when more is super slow. Okay? Waiting, waiting. Okay, I'm gonna back out. See what's going on. Let's see if I can get into the practice exam because I think it has the same directions. Okay, it seems that more is currently hung up. But here's what I wanted to tell you. I wanted to show you the directions for the exam. Please make sure you read them carefully, okay, and follow the directions. If you've got any questions when you start, shoot me an email and I'll be happy to explain things, okay? So again, what I'm going to do is I'm going to share a printed copy, my version of the exam, okay? And again, yours will be different. Okay, so different numbers and possibly different style problem, but same exact concepts. Okay, so let me get into my tablet. And share that with you. Okay, so again, this is a printed version, my version of the exam. So hopefully everybody can see that. Picture. Okay, and here we are. Right. This test is for practice. It's not time. Try to get it done in 3 hours. All right, since that's the amount of time you'll have on the exam. Okay, so you're going to get one shot at these, and the point is to show you what type of problems are on here. Okay, you are allowed to use any technology you choose. Okay, you can use Excel, you can use the TI-84, you can use Desmos, whatever works, Symbolab. Okay, you have to remember all the technology tips that I showed you. Okay, now take a look. Question 1 says, solve this system by graphing. Okay, so my attitude would be, I'm going to try to solve it using Desmos. Okay, so everybody get a chance to see how this works. Here's my question. Okay, if you want to write this down, do that. Okay, again, I'm going to upload my notes so you'll have everything solved out. Right. Now, one thing you can notice about this, okay, take a look at this system, okay? Notice that this equation, if I were to solve the first equation for y, I would have to subtract 2x from both sides. Okay, so that's the first equation solved for y. I don't need to do that if I'm graphing on Desmos, but you would need to do that if you're using a TI-84. Take a look at the second equation. I'm just copying it over bigger. What do you notice about these two equations? What do you notice about these two equations in question 1? Okay. Yeah, exactly. Same slope. The slope is this number that's multiplying the x. Okay. Do they have the same intercepts?
No.
No. Okay. So what you're seeing is a pair of lines that have the same slope but different intercepts. Everybody see that? Okay, so that tells you these lines are parallel. Okay, these lines are parallel. You don't even need to graph them. Okay, so basically, you know, you can certainly go over to Desmos, graph the two lines, you'll see two parallel lines. But what's important is, since graphing is inherently an approximation, you want some proof that, well, it looks parallel. Is it really parallel? And what gives you that proof is the same slope. All right. So if you've got two parallel lines, does the system have a solution? Is there a solution if the lines are parallel? Okay. No, no solution. So your answer to this question would be D and E. Okay. If the system is inconsistent, has no solution, that's what you would answer. Okay. Likewise, if the two lines had the same slope and the same intercept, then they're the same line, right? So then they'd have an infinite number of solutions in common, namely all of the points on each line. And so you'd have the infinity symbol in each box, okay? Anybody questions about the first problem? Okay, and again, if there is a single solution, you would find it by graphing. Okay, so I would imagine most people, if you don't notice, hey, these slopes sort of look similar before you even go to the graph, or most people would probably just graph. Okay, no questions? Okay, let's take a look at question 2. Okay, it says solve the system of equations. All right, don't give me an answer, but tell me, how would you do this? How would you do the problem? A process. Okay, and again, feel free to unmute yourself if you don't want to type. Just unmute yourself and give us a suggestion. How would you do it? Okay, Justine saying set up a matrix. Okay, now there's lots of ways to solve a system with a matrix. Okay, solve using a matrix. Are you going to solve it by using Kramer's rule? Are you going to solve it by using inverses? Are you going to solve it by putting an augmented matrix in reduced row echelon form? How are you going to do it? There's a bunch of different ways.
I would just put it in my TI-84 and multiply the inverse.
Okay, so one way is to multiply by the inverse. Okay, another way is to basically put it in, I think the easiest way is build an augmented matrix. Again, I'm trying to type in the chat here, build an augmented matrix. Although what she said would certainly work. Build an augmented matrix and then get it in reduced row echelon form. Okay, now I'm not asking you to do Gauss-Jordan elimination on it. I'm asking you to use a technology tool to get it in reduced row echelon form. There's an RREF function on a TI, and I showed you how to do that in Symbolab. Okay, so let's do it with Symbolab since I know everybody has that. But first I'm going to build the augmented matrix. So I'm going to pull in my coefficients and then my right-hand sides. Okay, and then I am going to do the next one. Again, it's important to make sure you understand where I'm getting the coefficients from. Notice the last equation doesn't have a z in it, so that's going to be 1, -2, 0 for z. So first column's x, then y, then z, constant. And this is -6. Okay, so that's the augmented matrix. Okay, everybody comfortable with that part? Then what we're going to do is we're going to go over to Symbolab, which I have open up here on my bar. Okay, I have the matrix calculator open in Symbolab. There's a link to that in your course. Okay, and then all I have to do is look at my matrix and I have to say, well, I have 3 rows and 4 columns. So I need a 3 by 4 matrix. Click on the right size. It'll give you a template and you put your numbers in. So I have 3, -6. I'm just tabbing across on my keyboard. Okay, and then -1, 1, -1, 1, 1, -2, 0, -6. Okay, so that should be the same augmented matrix. Again, the bar that's here is something I'm just going to draw that when I'm writing it on paper. I'm not going to, that's not necessary. Okay. And then all I have to do is hit go and Symbolab will know what I want to do. Okay, take this. It says reduce matrix to row echelon form, and it would show you the steps. Okay, what have I got here? What am I pointing at?
What your X, Y, and Z all equal?
Right, so here's what comes out of it. Okay, you wind up with 1, 0, 0. Okay, I'm copying it down, and then that way we can go back to the notes. Okay, and what's crucial to realize is this part of the matrix is in reduced row echelon form. What that means is you've got 1s on the diagonal and 0s everywhere else. Okay, another thing that can happen when you do this process is you could wind up with all 0s in this bottom row. And in that case, remember, that means you've got an infinite number of solutions. Z can be anything. Okay, and then you have to parameterize your solution. So solve for y in terms of z, solve for x in terms of z. But in this case, I've actually got numbers for everything. X is -2, y is 2, z is 3. Okay, so I'm going to go back here to my notes, and I've kind of written what's come out of our ref. Okay, and that's either RF on your TI or RF on in Symbolab. Okay, and then you just put in your values, -2, 2. Okay, anybody questions on this? Although if you wanted to do inverse, like take the inverse of the coefficients, multiply it by the constants, that would give you the same answer, but it's more steps. Okay, questions? How are we doing? Yeah. Okay. Let me show you an interesting one. Here's number 3. Okay, number 3 has decimal coefficients and constants. Okay, you're going to do it exactly the same way. The only trick here is the way this homework system, you notice sometimes it's not terribly precise about how many places to round to. For these answers, I would say state your answer in 4 decimal places. Okay, 3 or 4 usually. Okay, by all that's holy, since they're only giving you 1 decimal place in the coefficients, that's all they should ask for. But the way these questions are set up, they'll say things like round to at least 1 decimal place, which means if you put 2 or 3, it's still okay, right? As long as those numbers are correct, right? So again, what I would do here is I would build an augmented matrix. All right. Like that. And then I would RREF it. Okay, which again, you can do in Symbolab. Okay, you can do it on a TI-84. Okay, and again, it's just when you do it on a TI-84, let me show you something about a TI-84. Right, I'm going to put my matrix in here. So I know some of you have this calculator. So I'm going to get into my matrix menu. I have a 3x3 there already, so let me delete that. Memory management, delete.
I can't see it. The screen turned gray.
Your screen turned gray? Oh, I'm sorry. Thank you for letting me know that. It's a separate app. I need to share it. Okay, my bad. Emulator software. How about now? Can you see it now?
Yes, thank you.
All right, thank you. No, for saying something. All right, so basically, here I am. I'm going to go to memory management, delete. See memory up here. And the second one lets me clean up my garbage. And I have all the things I can clean up. I'm going to go down to matrix. And then with the arrow pointing at the matrix I want to get rid of, I'll just say delete. Right? And then second mode quits you out of anything you're in, you don't want to be in. Now let's go into second matrix. I'm going to go all the way over to edit. And I'm going to build this augmented matrix. So this is a 2x3. Okay, and then I'm going to just put in the coefficients. Oh, right, I can't do that. Sorry. I have to use the keyboard. Negative 6.8, and then 10.4, 45.2, right, then 8.4, 11.5, and the last one is 35.7. Okay, so there's my matrix of my coefficients and right-hand sides. I'm going to quit out of here, get back into matrix by second inverse, and go to the math menu and get down to RREF, which is B. And then I'm going to put matrix A in there. So second matrix from the names menu. And you can see my values here. Okay, so carry 4 decimal places. All right, so for X, we're getting negative 0.8971. Okay, if I were to carry a 4th decimal place, that's the 0, but this 7 means I'm going to round it up. Okay. Likewise, with the other number, I have 3.7596. Okay, and the next position is a 0, so the 6 stays a 6. All right. So I put my answers in my answer box. Okay. Also, folks, I'm pretty sure it's in the directions for the exam, but if you write down your work as you go along, even if you use Desmos or you use Symbolab, just basically say, here's what I typed in, like I'm doing here. Here's what I typed in. I did RREF. Here's what came out. Okay. Basically, what I'll do is I can give you partial credit. Say you loused up on a rounding problem here. Well, the homework problem is going to mark the answer wrong. Okay. But you got the right answer. You just had a rounding problem. Okay. So if you show me your work, okay, and you can email me that work, okay, when you finish the exam, okay? So just what I'm saying is you don't have to do it as part of the time limit for the exam. Just make sure you're doing work on paper and then either take a picture of it or scan it in if you have a scanner send me the pictures or the file. Okay, and then that way I can go through and give you partial credit. Okay, because you're all familiar with how these automated homework problems, are very severe in the way they grade. If you have any problem at all with the answer, it's wrong. Okay, so I want to make sure you have that flexibility. Does everybody understand that? Okay, understand the idea of showing work? Okay, understanding work. Good. All right. Okay, again, find the reduced row echelon form of this matrix. Again, in this example, a lot of you may assume, oh God, I have to do Gauss-Jordan elimination because it looks like they started the process already, okay? But not so. You can take this matrix and put it in Symbolab, okay? And then just say go, and it will put it in reduced row echelon form. Okay, so let me go back to Symbolab. Right, and I'm going to go up here and I'm going to clear out what I had. Okay, this matrix is a 3x4 again. And I had -1, 0, 1, 200, -2, 1, -1, 300. Oops. Not going to like that, is it? And then the last one is -2, 0, 1, 250. All right, so that's the matrix they gave me. And even though it's part way there, I can just say go. And in this case, what you're going to need to do is copy the entire matrix. Okay, so we need to copy the entire matrix. The left-hand side should look like a 1 on the diagonal, which you can see, and then zeros everywhere else. And that last column is showing you the values of the variables, which again, they're not telling us. There's no context to this problem. But what you need to do in order to answer the question is copy the entire matrix. Okay, so your answer is going to look like this. Okay, so copy. Okay, so that one's straightforward. I'm sure a lot of you are looking at this saying, oh my gosh, I can do this whole test on a calculator. Well, almost, okay? I put questions on here that you can do on a calculator and do very, very rapidly because you're going to need most of the time to do the word problems, okay? So I didn't want to overwhelm you with lots of word problem questions. Okay, there are a couple on this test, but they're the ones that are going to require most of your time. So suggestions for doing this test is go through it first, look at the whole test, and then do the easy problems first. Okay, like these, the ones that are easy to do on Symbolab. Then spend the bulk of the time on the exam working on the word problems. Okay, so don't do the test in order. I'm pretty sure I set it up so you don't have to do it one question at a time. Okay, you can, look at the whole test and pick and choose. Okay, this is another one where, again, I'm going to basically put this in Symbolab. This one's even closer to reduced row echelon form. So all I would have to do here is clear out this first column, clear out the second column. I'd have to continue. I'm not going to waste time doing it. I'll just show you what comes out of Symbolab if you want to check. But this is what you would need to put in as your answer. Okay, so copy entire matrix. Alrighty, so everybody's good with these, relatively straightforward questions. Okay, here's another one. Okay, again, symbol lab. Okay, I want to make sure you can use the tools. Again, if your calculator of choice is a TI-84, we showed how to do it there. All right, so again, I'm just showing you what came out when I did it. Whoops. All right, and then this is negative 39. Okay, so again, straightforward. Now, we're down to the word problems. Okay, so these are the ones where you're doing, you're trying to change the words into something to solve. Okay, now if you take a look at these, a collection of dimes, nickels, and quarters consists of 16 coins with a total of $1.90. Okay, so the 16 coins are worth $1.90. If the number of dimes is equal to the number of nickels, find the number of each type of coin. Okay, first question to you is this an optimization problem or a system of equations problem? Okay, so is it a linear programming problem where you're trying to maximize and minimize, or is it solve a system of equations? Which one? How would you know? Here's a hint. Yeah, system of equations. Good for you, Daniel. It's a system of equations problem because you're not seeing the words maximize or minimize, are you? So it's not a linear programming problem. Okay, again, part of it is approach the words and deconstruct the words. Don't just jump in and do math. Okay, figure out what you're looking at. Okay, there's no maximize or minimize something. Okay, so basically, it's a system of equations problem. So the first thing I'm going to do is figure out what I need to know. Okay, it's asking me find the number and type of each coin. How many different types of coins are there?
3.
There are 3. Okay, so I could say let X be the number of, what do I have? Quarters, nickels, and dimes. Okay, so let X be the number of nickels. Let Y be the number of dimes. And let Z be the number of quarters. Again, write it down so you know what you're doing. Okay, so those are my 3 things that I want to know. And I'm going to solve for those. So I need to set up a system of equations. Well, what 2 things do they tell you about the coins? What 2 things?
The number of coins and how much they equal.
Yeah, you know 2 things. You know a count. Okay, so again, up here, you've got a count. And you've got a value. Okay, they tell you those 2 things about the coins. Well, the count of coins means all of them together, right? So one equation is X plus Y plus Z. That means the nickels, the dimes, plus the quarters means there's 16 coins. Okay, so here's my count equation. And then I have another equation that has to do with value. Okay, the coins are worth $1.90. So if you're going to do a value equation, you need to multiply the number of each type of coin by its value. Okay, if I'm going to use 1.90 as the total value, What's the value of a nickel? Yeah, 0.05, okay? So again, a lot of people multiply this equation by 100 to get rid of the decimals. You're going to use technology to solve it. You don't need to waste your time doing that, okay? That's more important if you're going to solve it by hand, okay? So here's my nickels, my dimes, and my quarters. Okay, everybody see the values? Okay, so you turn this into a matrix, an augmented matrix. And again, 0.05, 0.10, 0.25, 1.90, and you are ref. Okay, either on your TI-84 or on Symbolab. Okay? Do you need me to show you how to do it again? If you need to see it in Symbolab. Okay? Again, I want to make sure I get to show you what you want to see. Anybody need to see it in Symbolab? If you need to see it, type a yes in the chat. Well, when I, okay, no, 2 no's. Anybody need to see it? Anybody want to type a yes? So again, when I RF'd it, I got 6 nickels, 6 dimes, and 4 quarters, and you can see that that adds up to 16 points. Okay, at least you can check that one. Okay? So you would just put those in there. Okay, let's take a look here. All right. Again, this is a problem that, take a look. They're telling me admission fees for children and adults and how many people entered a park and what the gate was. In other words, how much did I take in? And they're asking how many children and how many adults were admitted. So what do you think? Is it optimization or system of equations? Which one? Yeah, yeah, system of equations, because again, no maximize or minimize, right? So we're asking how many children and how many adults. So let's let X be the number of children. Let Y be the number of adults. Okay, and again, I have 2 pieces of information. Okay, they're giving me values. Okay, so a child gets in for $1.50, an adult gets in for $4, and we collected $710 that day. Okay, so there's a value equation, and then here's a count equation. So here's count, and the other one is value. Okay, so I'm going to do the same thing. I'm going to build a count and a value equation. So for count, I have X plus Y, because there's only 2 types of tickets. So here's count. And then value, I can just multiply by the price. Okay, so children pay $1.50. Adults pay $4. And the total take was 710. Again, here's your matrix. You've got 1, 1, 265. Again, I can abbreviate the 150 is 1.5. All right, so there's my augmented matrix, RF. Again, either in the TI or in Symbolab, and you'll get . Okay, and if you look at those numbers, you can see they do add up to 265 people. Okay, so far these are not that complicated. Okay, the next two are more complicated. Okay, so these are like easy peasy kind of ones you might have seen in, intermediate algebra or introductory algebra. Okay, let's take a look at this one. Try to make this a little bigger. Okay. Maui Surf Company makes custom-made surfboards at shops in Lahaina and Hana, both on the island of Maui. As a supply chain manager, you must coordinate the distribution of its surfboards to Kanapali Beach and Ho'okipa Beach. The Lahaina shop can make 155 surfboards, while Lahana shop can make 165 surfboards annually. Kanapali Beach orders 145 boards, and Ho'okipa Beach orders 175 boards. You have an annual transportation budget of 5,160, and the costs from each shop to each beach are as follows. Now notice, Lahaina to Kanapali is expensive. Lahaina to Ho'okipa is even more expensive. Okay, so different transportation costs because the beaches are in different places, right? Hana to Kanapali, 25, and Hana to Ho'okipa, 18. So you've got 4 different transportation costs. Assuming you wish to fill all the orders, how many boards are shipped from each shop to each beach? Okay, I'll ask you the same question. Is this an optimization, a linear programming problem, or a system of equations? What kind of problem? Are we trying to maximize or minimize anything? Yeah, it's system of equations again. Okay, so again, how many boards are shipped from each shop to each beach? What you have to ask yourself is, how many combinations have I got here? I've got 2 shops and 2 beaches, so how many combinations? Anybody? Take a look at the words again.
Four combinations?
Yeah, there's 4. Okay. So again, forgive my weird writing, but I'll put it right here. Lahaina to Kanapali. When I first started doing this problem, I said let X be number of boards, and I wrote it like this: Lahaina to Kanapali. Okay, so that's that first box. Then I said let Y be the number of boards from Lahaina to Ho'okipa. Okay, that's the second box. And then I said, oh wait, I'm going to need an extra variable. So I said, let's let W be the number of boards from Hana to Lahaina. Okay, and you can see why it's critical that I basically Hana to Kanapali. I'm sorry, Kanapali is the beach. Okay, and then let Z be the boards from Hana to the other beach, Ho'okipa. Okay, in this problem, it's absolutely critical that you identify what you're talking about. Okay, All right, now let's see what we know about all of this stuff. Okay, we know that the Lahaina shop can make 155 surfboards. Okay, so let's see that over here. Lahaina can make 155 surfboards. Okay, so I have to look for all my Lahaina shop variables. That's X and Y, right? So X plus Y equals 155. That's what Lahaina makes. Okay. The Hana shop can make 165 surfboards. So Hana can make 165. Okay, so I look for all my Hana variables. That's W and Z equals 165. Okay, then I have to look at what each of the beaches order. Okay, so I'll try to underline these. Okay, Kanapali orders 145 boards. So I have to look at my variables and find the variable that deals with Kanapali. So that's X and W. So these are the orders from Kanapali. Okay, so maybe it'd be better if I did it like this. I'll write what these are from Lahaina. Okay, this is to Kanapali. Okay, so the Kanapali variables are X and W. And we said that was 145. All right, and then the other one is Ho'okipa orders 175 boards. So I look for the destination beach, Ho'okipa, that's Y and Z. Kind of looks like a spreadsheet at this point, doesn't it? Okay. And then there's one more piece of information. Okay, there's one more piece of information, and that is the cost. Okay, so the cost of shipping is different for each place to each beach. Okay, so what I can do is I can look through the words in the problem, and then I can basically put the shipping cost next to each one of these. Okay, because it's different for each one. Let's see, let's try green. Okay, so to go from Lahaina to Kanapali, that's $6 a board. Okay, to go from Lahaina to Ho'okipa is $13 a board. And Hana to Kanapali that was the expensive one, 25. And Hana to Ho'okipa, 18. Okay, so those are all my shipping costs. And you notice there's a separate one for each variable. Okay, and again, we have a transportation budget of 5,160. So that means 6 times X plus 13 times Y plus 25 times W plus 18 times Z must equal 5,160. So this is costs, shipping costs. Okay. Is everybody okay with the equations? Everybody okay with the equations? Okay. The rest of it is to just set up a matrix and keep track of your variables. Okay. Now, I made an unfortunate mistake. I should have started with W, so then the variables would have been in order. W, X, Y, Z. When you do the problem, do it that way. Okay. So then you would have had Lahaina to Kanapali being W, X, Y, Z, so forth. Because mine are out of order, I have to be careful when I set up my matrix because I'm going to set it up so I have W, X, Y, and Z, because that makes sense. All right, here's my constant. Okay, so my first equation, X plus Y is 155. So that's 0 for W, 1 for X, 1 for Y, 0 for Z, 155. That's my first equation. Okay, my second equation has a W and a Z in it, and no X and Y. And the right-hand side is 165. Okay, third equation has a W and an X, no Y, no Z, 145. Okay, then I have a Y and a Z, so that's 0, 0, Y, Z, 175. And the last one, again, be very careful where you're putting your numbers, okay? 6 goes with X, 13 goes with Y, 25 goes with W, and 18 goes with Z, 5160. Okay? Everybody all right with it? Anybody questions?
No questions.
Yeah, okay, good. And then you just do the same thing, you ref it. And I got values like this, 60, 95, 85, and 80. Okay, and again, you can check some of the things, namely Lahaina is shipping a total of 155 boards, which is right. Kaanapali Beach is taking in 145 boards, which is right. Okay, so at least that much checks. Okay, so again, just please be careful when you set it up. All right. Weird about this one is a lot of different variables. Okay, there aren't just 3 things or 2 things, you've got 4 things. Okay, any questions? I'm guessing not. All right, so let's take a look at this next one. This next one is also a little bit involved. Okay, a chemist has 3 different acid solutions. Okay, and they're all at different dilution levels. The first solution is 20% acid, the second is 30, and the third is 75% of whatever. We're assuming the rest of it is in some kind of a solvent, usually water. Okay. The chemist wants to use all 3 solutions to obtain a mixture of 78 liters containing 40% acid. So he's trying to get an acid concentration somewhere in the middle of the 3 that he has. He's got one that's really strong and 2 that are kind of weak. All right, so he needs to kind of mix them together to get the dilution that he wants. Now, maybe he's got a problem. He wants to use twice as much of the strong solution as the weaker, the middle solution. Maybe he doesn't have enough of the 30% solution. Okay. So how many liters of each solution should be used? Okay, so here's the question. I'll save you the trouble. It is an ecosystem of equations problem. Okay, so how many liters of each solution should be used? Well, I've got 3 different solutions. So I'm going to say let X be the number of liters of the 20%. Okay, let Y be the number of liters of the 30%. And let Z be the number of liters of the 75%. Okay, so I have 3 different concentrations, and those are what my variables are going to be. Okay, so the first thing I know is all of this stuff, once I'm done mixing, has to add up to 78 liters. Okay, so I have an amount. Okay, that's kind of like the count before of people, only this is an amount. So I know X plus Y plus Z, since these are in liters, that has to equal 78. So total liters. Okay. And then what you've got is kind of a concentration. Okay, how much acid? Okay, so how much acid? All right, so X is your 20% solution. So the amount of acid in that is 0.2X, right? It's a 20% solution and you've got X liters of it. So 20% of those liters are the acid, okay? This is a 30% solution, so 0.3 times Y is the amount of acid in those liters. It's the number of liters of acid in that part. And Z is 75% acid. So 0.75 times how many liters gives you the number of liters of acid in that. Now, how do you figure out what goes on this side? Okay, so what's the right-hand side? What's the right-hand side? It's the number of liters of acid in your final solution. How would you figure that out? Look at what they said the final solution should be. It should be 40% acid, right? How many liters are in the final solution?
70.
78, right?
You multiply.
Yeah, so take 78 times 0.4. Okay, that'll tell you how many liters of acid will be in your final solution that you want to be at 40% concentration. Okay, so I got 31.2. Oops. Switch back to black. Okay, so basically I got 31.2 liters. Does everybody understand how I did that? Okay, this is asking you how many liters of acid are in each one of these. Right? There's one more constraint, and that's due to probably a short supply. Okay, the chemist wants to use 2 times as much of the 75% solution as the 30. Okay, that means his amount of 75% solution has to be twice the amount of 30. Okay, please take a look at this last equation. Almost everybody who does this does it backwards. Okay. All right, so let's give this a shot. Okay, and again, you put this in a matrix. Remember, you need to rewrite this last equation so it's in standard form. Okay, so your matrix would look like this. 1, 1, 1, and 78. 0.2, 0.3, 0.75. And this one would be 31.2. And then you have 0, minus 2, 1, 0. Okay? So again, the trick here is remember how to calculate the right-hand side of the concentration equation. You take the total amount that you're going to have at the end in liters, you multiply by the concentration of your final amount, and that gives you this right-hand side, okay? And then when you put your equations in the matrix, remember they have to be in X, Y, Z form. So X, Y, Z. Okay. And then when I RF'd this, I got 39 liters of the 20%, 13 liters of the 30, and 26 of the 75. And you can see I've got twice as much of the strong solution as that medium solution. Okay. Anybody questions on the number 10? Questions on 10? Okay, a lot of this should be review for you, but it was so long ago, it probably is, shrouded in the mists of time. So this is kind of an occasion to make sure you know how to actually translate the problem into a system and then into a matrix, and then offload the solving onto technology, okay? Because if you're doing real world problems, right, like this could even be somebody who owns a coffee shop and they have different varieties of coffee. One's really expensive and two not so much, and you want to make a blend, okay? Basically, how much of each coffee should you mix together to get, say, 10 pounds of this blend? If you mix it together wrong, you're going to lose money on every pound you sell, okay? So it's important to be able to do stuff like this, right? But use the technology to do it, okay? All right, not seeing any questions. I'm going to move on. Okay, question 11 is another simple one, okay? First of all, is it possible to add these two matrices? Take a look at matrix A and matrix B, okay? And is it possible to add them? What do you think? Yep, it's possible because they're exactly the same dimensions, okay? So to add or subtract, the dimensions must match, okay? You're more than welcome to use Symbolab to do this, okay? So you take matrix A, you take matrix B, you go over to Symbolab, which I'll do right now. Okay, I'm going to this out of the way. Right, both of these matrices are 2 by 3. So I'm going to say 2 by 3 and put my values in. -3, -5, 3, 5, -5, and 2. That's my first matrix. I'm going to put a plus sign in here. And then I am going to put in my other 2 by 3 matrix, which is 5, 4, -2, -3, oops, and -5, -5. Oops, like that. Then say go. And here's your sum right here. Okay, so your sum is 2, -1, 1, 2, -10. Okay, everybody see the sum? Okay, so just use your plus sign and remember, copy the sum. Alrighty, so far so good. Coming down the home stretch. Okay. Question number 12 is just saying you want a scalar multiple of the matrix. So that means multiply each entry by -5. Okay, that's something I can probably do in my head. Okay, but again, you're more than welcome to do that in Symbolab. The way you do it in Symbolab is you put your -5 out in front of the matrix, and it will do the multiplying. Okay? Same thing with the TI-84. Just put 5A where A contains your matrix, and the calculator will know you need to do a scalar multiply. Okay, any questions on 12? Anybody need to see anything with 12? No? Okay. Let's take a look here. All right. I have two matrices. I have matrix A, which is a 3 by 3, and matrix B, which is a 4 by 2. Is it possible to multiply them?
No.
Yeah, no, it's not possible to multiply them because you've got this going on. Okay. Not possible. Okay, so you would say not possible. All right, now again, I took a look at this question because I thought it was weird that it always showed part B. Okay, if this question, if you wind up with a not possible and it's expecting an answer here and it marks you wrong, don't worry about it. Just make sure in your notes, your work for the exam, you write down what I just wrote here saying, I can't multiply these because these, the columns of the first don't equal the rows of the second. So there's no way to do it, okay? And you get full credit, right? However, if these two dimensions did match, okay, you would basically put your multiplied answer here, okay? Like for example, everybody remember how to do this in Symbol Lab. Okay, to multiply matrices in Symbol Lab, you just put them right next to each other, right? So for example, suppose I have a 2 by 2 and another 2 by 2. Okay, this is the 2 by 2 identity matrix. Okay, so what should I get when I multiply these? Okay, the second matrix is the identity matrix. So I should get a 2 by 2, but what will its values be? What would the elements be?
It'll
This is
have
like
values because it's giving it it's like multiplying it by 1.
awesome. Exactly. This is the matrix version of 1 for a 2 by 2 matrix. So I should get the matrix 1, 2, 3, 4 back again. But I'm just showing you how to do multiply. You just put them right next to each other, and here you can see the answer. Okay. So again, everybody should be comfortable using Symbol Lab to multiply matrices. Yeah. Okay. But in this case, you would leave part B blank because there's no product. Okay. Again, finding the inverse of a matrix. Okay. On a TI-84, you would do this. You would put matrix A in the first matrix, and then you would do this. Okay, and on Symbol Lab, you say inverse 3, 1, 2, 1. Okay, so let's head on over there. So it's slightly different syntax depending on the tool you're using. Okay, so the matrix I want in inverse is 2 by 2. And it is 3, 1, 2, 1. And I just put the word inverse in front. Okay, and here's the inverse. Okay, and I'll write that down. 1 minus 1 is 2. Okay. All right, questions on using either tool? We're good with that? The next one is actually asking you how you would use matrix inverse to solve a system of equations, which is another method we've used. It says, write the system of equations as a matrix equation that is rewrite it in the form of A times the vector of the variables equals B, where A is, well, what am I going to pull out of this for A? What goes in A, folks?
Your coefficients.
Yeah, just the coefficients, okay? So I'm going to just take the coefficients. All right, and B is the constants on the right-hand side. Okay, so it's just 2, 4, minus 4, minus 5, minus 1. Okay, and this is minus 5, 3. Okay, they're not even asking me to solve it. Okay, if I wanted to solve it, which is not part of the problem, I need A inverse. Okay, and I would do this, A inverse times A. Okay, this matrix here is usually called capital X. Okay, so multiplying both sides on the left by A inverse. Okay, A inverse times A is I, the identity. Okay, which means X is A inverse times. Okay, so you would take your inverse of your coefficient matrix and multiply it by the constants. Okay, and then that would give you the values of the variables. Okay, remember this we kind of talked about as being part of linear algebra. Okay, which some of you may see again if you take an advanced stats class. Okay, any questions on 50? Okay, let's take a look. Okay, given the matrix A, find its determinant. Don't do it by hand. Okay, you're either going to use DET A on the TI-84 and DET for 2. I think I have to spell out determinant on symbol lab. I'm not sure. Let me go back over here. So let's see. Right, and this was, again, this had values 1. This was a 4, a minus 2, and a 5. Okay, so your determinant is a number. Remember, it's just a number, 13. Okay. All right, so just again, use technology to do that. All right, so here are my values that I've put in. Kramer's rule, okay? Kramer's rule is long and drawn out. let me ask you a question. You can use Kramer's rule, of course, and Kramer's rule is pretty much where you find the determinant of the system. Okay, you find the determinant with these constants replacing your x, and then your determinant with the constants replacing y. Okay, so you wind up with, again, a system over here. Okay, so you find the determinant of this matrix, which I wound up doing, and I got 20. Okay, then what you do is you replace the, hold on. Okay, so the determinant of that is 20. Then what you can do is you replace the x's with -3, -9, and you leave the y's alone. You take the determinant of that matrix, that's this one. Okay, and I got -60 for that. And then you take the same matrix and you replace the y column with the right-hand side. So x stays the same, and the y column is replaced with -3, -9. Okay, everybody see how this column winds up here and here, okay, when you're trying to find the determinant. All right, and that gave me a 0. Okay, and I'm using the DET or the determinant in Symbolab. Okay, then Kramer's rule says x is d sub x over d. Okay, so -60 over 20, which is -3. Y equals d sub y over d, which is 0 over 20, which is 0. Okay, so x is -3, y is 0. Let me ask you a question. Is there anything in this problem that says you must solve it with Kramer's rule other than the directions? It's just asking you for x and y, people, right? Okay, it'd be a good thing to know how to use Kramer's rule, but you could solve this with any method you choose. Okay, it would work. However, if you get it wrong and you show me work that doesn't involve Kramer's rule, I'm not going to give you partial credit because the directions say use Kramer's rule. Okay, so hopefully if you're showing me work here, you're going to use Kramer's rule to do it, yeah? Okay, any questions on 17? You good with 17?
A quick question, I might have missed it because I was finishing up 16. How did you get d equals 20 again? Was that given? Or?
Okay, it's a determinant. Okay, so you just go over to Symbolab, put in this matrix, and put determinant in front of it. It'll give you 20.
Got it. Thank you.
Yeah, the trick to Kramer's rule is just knowing how to build these other two matrices. Just take whatever column you're interested in, like this one's x, that one's y. If you're looking for d sub x, just replace the x column with the right side. If you're looking for d sub y, replace that column with the right side.
Okay, great. Thanks.
Yeah. The Kramer's rule is great if you only need to find the value of one variable and you don't want to go through the bother of, solving the system. But now that we've got technology, solving the whole system is no big deal. Okay. So again, all of these things were developed years and years ago when this was tedious and done by hand. Okay. Let's look at 18. All right. So is this a linear programming problem or is this a system of equations?
Linear programming.
Yeah, linear programming. And again, you can see because, well, duh, they tell us. That's nice of them. Okay, but here's the dead giveaway. Maximize. This one says minimize. This one says maximize. Okay. Now, they say by graphing, okay, which means you can do this with Desmos. Okay, so the idea again is if you're gonna do this, okay, and show me work, okay, basically you graph this to get corner points. So essentially, I'm going to look at these inequalities, okay, and then I'm going to get a list of corners of a feasible region, right? And then I'm going to evaluate my objective function, okay, which is P equals 10x plus 25y, okay? Now I can hear some of you thinking really loud, can I use Excel to do this? Yes, of course, okay, provided you set it up correctly, okay? But again, the problem asked graphing, so please show me your work as if you did it graphically. Show me a table of corner points, which you won't get from Excel, okay? So let me just go up to Desmos and we'll graph this really quick. Okay, so I'm going to graph all of my inequalities, which is 5x plus 2y. And the first one was greater than or equal. Remember, those are in the keyboard down here. Okay, so first inequality. Second inequality says x less than or equal 10. And third inequality, y less than or equal 15. Okay, and then what I need to do is I need to, this is probably a first quadrant graph. I need to zoom out a bit to see everything. Okay. Remember, all of these optimization problems are first quadrant graphs because your values of your decision variables have to stay positive. Okay. And x and y are both positive in quadrant 1. So once you see this area that's shaded multiple times in quadrant 1, click on its corner points. If they're black, they'll stay clicked. Okay, so my corner points are going to be 215, 1015, 80, and 10, 0. Everybody good with the graph? Good with the graph? Okay, you just graph the inequalities the way they appear. Okay, use the inequality symbols from the keyboard that comes with Desmos, and then click on the corner points, write them down. Okay, once you've got your corner points, like I have here in this table, then I'm just going to evaluate P at each one of them. Okay, so P is 10 times 2 plus 25 times 15. And if I evaluate that in my calculator, that's 395. Then I have 10 times 10 plus 25 times 15. And if I evaluate that, that's 475. Then I have 10 times 8 plus 25 times 0, that's 80. And then I have 10 times 10 plus 25 times 0 is 100. I look back at my problem, I was trying to maximize. So my maximum value is 475 when x is 10 and y is 15. So I make sure to put those in the box. Okay. All right. The other two problems are pretty similar. You can see this is a minimized problem. Okay, so this may have an area that opens up, okay, rather than being a closed, contained area. So again, these are going to be both done on Desmos. Okay, so again, I would do the same thing. I would get corner points. And then here I would have my C value. Okay, I'll just graph the minimization one just so you can see how it looks different. And I won't bother graphing the last one because it's a maximize and it's the same idea as question 18. So I'm going to clear all of this. Right, and that first inequality is x minus 2y is greater than 0, greater than or equal to 0. X plus y greater than or equal to 210. And the last one is y less than 100, less than or equal to 100. Right? So those are the inequalities, and then I'm going to zoom out a bit so I can see my feasible region. Okay, the feasible region is the region that's shaded 3 times. Okay, and remember, it has to be bounded by my x and y axes. All right, so here's the gray part, here's the blue part, here's the red part. So I have to get gray, blue, and red all together. So here's one corner point, here's another corner point, here's my other corner. Okay, so here are my 3 corner points. Okay, so I would put them in my table, and then I would evaluate my objective function at each corner. Okay, you're usually missing a corner point when you have a minimization problem, because again, this, if you can see, this opens up like forever this way. Okay, so I'm just going to take these corner points and I'm going to put them in my table. Right, and then I'm just evaluating my decision, my objective function at each of the corners. Right, so that'd be 3 times 200 plus 2 times 100. Okay, then I have 3 times 140 plus 2 times 70 and 3 times 210 plus 2 times 0. Okay, now here, since I wanted to minimize, okay, I'm looking for the minimum value of C. Okay, and that's going to happen when X is 140, Y is 70, and C is 560. Okay. Anybody got questions on the optimization? Now, if you still have time and you want to check these in Excel, by all means, check them in Excel. Okay, that's kind of the way you're going to do it in the real world. You're not going to be graphing things, you're going to do it with Excel. Right? And again, feel free to do it in Excel if that's what you want to do. Okay, these would be your constraints, that's your objective, and put your decision variables further up in the spreadsheet. Okay, I'm not seeing any questions on optimization, so I'm going to stop sharing for a minute and come back to the meeting screen and ask if you've got questions on anything. Okay, including the exam, practice exam, showing you work. Okay. Some of you were still struggling with the 1.9 problems in Excel. Please email me again. And again, I just ask that you double check your email to make sure you're getting my responses, okay? But if you don't have any other questions, I have nothing else. Yes, and absolutely, Chelsea's saying, how about over the weekend? Yes. If you want to ask me questions over the weekend, by all means. Okay. Again, it's my goal is to turn around my answers quickly. Okay, so if you don't have anything else right now, that's all I have. Feel free to drop off when you're ready.